Now, without further ado, I'm going to introduce Remmelt Pitt. Remmelt has been working on our IoT side project, which is actually no longer a side project anymore. And recently we took all those learnings and integrated, or he took all those learnings, integrated it into another tool called Mantl that we're working on. And he's going to be talking about that.
Thank you. Right, I'm going to be talking about the Mantl demo app, which is this Wheel of Fortune that you see there. But first, who knows what Mantl is? I see a couple of hands, but this is good because I have this slide. So let's say Cisco wanted to, you all know who Cisco is, right? Right, I guess. Right. So Cisco wanted to set up large-scale systems on their cloud. You know, it is, they want microservices, they want DevOps, they want IoT, you know, all those buzzwords. Basically, they wanted to hang out with the cool kids. As you probably are aware, there are loads and loads of tools and services that can support a modern microservices framework like Consul, Mesos, Marathon, you know. But these tools never really work well together out of the box. You have to install them in a certain way, and then you have to have all these glue code that ports data from this to there. And you know, everybody that's building microservices is inventing their own microservices stack. So we thought this should be better. We have to do something about this, right? Which is why Cisco created Mantl, and now we're co-creating it with them. Besides writing software, we create, and I'm gonna cheat and look what it is again. We create information design. Thank you. Which means we have all kinds of super interesting and beautiful diagrams that explain what Mantl is and how it works, and you know, and we have beautiful bubbles, and of course it's shaped like a cloud because obviously. But what I'm thinking is that you're not here for the sales talk. What I'm thinking is you're here to know about what's really going on. You can't even read this probably. So let's go without further ado, get into that. From the bottom, we have Terraform that provisions servers. So it's a bunch of Terraform providers and scripts. There's a huge amount of Ansible roles, and with that it sets up the infrastructure, right? Besides that, there's a bunch of glue code. These are not sexy, so this is why this slide is also not very sexy. And with glue code, I mean, for example, you run or you schedule a container on Marathon, and the data from Marathon needs to go to Consul. The problem is you don't have this doesn't happen automatically, so you have to have some kind of bridge. So a Marathon to Consul bridge, or a Mesos to Consul bridge, or something like that. Now this is not very difficult code to write, but it is expensive because you have to maintain it. You have to write it first, and you have to maintain it. And when a new version comes out, you know, you're fucked because you have to write it again, basically. Right, so the third part of Mantl is a bunch of frameworks that we also write. And the problem with that, so you showed this before, right? So the problem with this is it's currently very hard to, so frameworks are drivers for running things on Mesos. So you can't natively run, for example, Elasticsearch on Mesos. Right, so a framework is then a driver. The problem with writing frameworks is that it's you know, kind of hard. You have to have you have to use an SDK, and you have to know. Do they have to be in Java?
No, you can write them in any language. You have to know the APIs.
All right, so it's kind of hard. Thank you. But we're doing two things about that, or Mesos is doing one thing, and we're also doing the thing. Mesos has come out with an HTTP API for making things much easier, so you don't have to use the SDK anymore. You can now go through an HTTP API, and we've created Mini Mesos, which was probably also mentioned before, and it's a testing rig for testing frameworks. So let's say if you want to do some automatic testing on a framework, You don't have to deploy it into an actual cloud and then run your test and then destroy the cloud or destroy that cluster. You can just run it in Docker. So it's Docker startup time, which is fairly quick, as we know. So, are you interested yet in Mantl? Lukewarm, guys. No, exactly, and I'm not either, because this is not how you talk to a set of engineers. This is there's no front end to show off. There are no cool screenshots. It takes way longer than 5 minutes. I have no idea how long it takes to set up, but it takes way longer than 5 minutes. So the 5-minute rule, it's out the door. So how can we get people to play with this? How can we show it off? So we thought we'd make a demo app. The problem with that is when you start making a demo app, we say, what can we do? Maybe make a reference implementation. But a reference implementation for what? Are we just going to show off the tools or then the frameworks and the services that Mantl consists of? Or are we going to make a reference application for creating microservices? Well, we decided to do the former because we wanted to give total freedom for developers to do their own thing on Mantl. All right, so the demo app. Mantl is a work in progress, and it's under active development. Is there a beta version? Zero. There's a 0 in the name. But we want to talk about it, and we want to show it off at conferences. And as some of you may know, we just flew back from DockerCon last night. We wanted to have something cool that we can put near the booth, and that will make people come to us and think of us in a positive way. So what do we do? Well, another buzzword is IoT. So how do we get what's a cool demo app? Our initial idea was to have people sit on a home trainer and cycle really hard. And then, that would generate something which would then be caught by... we explained this to Jamie here, and he totally misunderstood. And he thought that we were talking about the Wheel of Fortune. Well, all right, okay, so we can work with that. And it's probably also much easier to carry on a plane and all that. Because, so how do you get a Wheel of Fortune? You go on Marktplaats. And on Marktplaats, there's a dude named Spider. Spider is the man to go to for wheels of fortune or other wheels. Anyway, so I called this dude up. Turns out he's a 70-year-old guy from Drenthe, from Ruinerwold. I have no idea where that is, but it's probably far from everywhere. So I call him up, and we arrange, the colors, and this one's actually kind of nice, but there was another picture there before, but it wasn't so great. So a white one will do, and we discuss a price, and I thought, what about a down payment? Do you need anything like that? No, just I'll make it, and then in 2 weeks I'll send you a picture, and if you then still want it, you can decide to send the money, and then I'll send the wheel. I thought, all right, so this is how people do business in Drenthe, apparently. So after a couple of weeks, because he's 17 all, we received the wheel, and it's nicely packed. Now, the thing is that if you make unpacking party videos in portrait mode, then it doesn't fill the screen. But I'm an engineer, so I have fixed that for you. Look how awesome this is. Yeah, look at us go. Anyway, there's it just keeps looping, so I'll just start talking again. We fly off to DockerCon. Here you see our booth, and everything is nicely set up. There's a dude sitting there, and he's got a Container Solutions t-shirt on. It's looking pretty nice. And with that, we have a a corresponding demo app. So the wheel is it's a request generator. If you spin the wheel, requests go through the USB cable to the cluster. Now I'll explain a little bit what this looks like. This is a whiteboard demo. So on the side here we have a wheel of fortune that has an IoT device. I'm going to show this. I'm going to show this off because it's so cool. IoT. Sorry? Oh. Yeah? Oh, yeah, we cannot really change that, I guess. Yeah, but that's worse. Anyway. Yeah. Okay, so this sends requests through a Python script to a load balancer. In my case, that is traffic, because it just came out and I wanted to play with it. That is basically what that is. Traffic balances load over any number of backend services, which are visualized by these bubbles that you see here. And these guys are scheduled by a Go application, because why not? Which is running on Marathon, and this is not actually running in the cloud. This is on my machine there. So this is running on Mesos. Here we are, running on Docker. I'm doomed. Here, it's running on VirtualBox. So on the back, it's running on OS X, and there we have the actual laptop that is, the hardware. And they don't call us full stack developers, right? I don't know. So anyway, the wheel sends requests, and then the requests end up here, sends a response back. But there's something special going on with these backend instances. They have a limited lifespan. So what's going on here is this guy has a lifespan of 29. Can you read that in the back? And it's already had 6 requests. After 29 requests, it will die. It will feel very sad and it will just leave violently. And this is all for a laugh and for a conference booth. But one of the insights that we gained from this was that scaling down is actually really hard, because even if your services are stateless, which service can you reliably kill? Yes, they're stateless and there's no data stored in there anywhere. But if a response or a request comes in and you kill it right then in transit, there will be no response, right? So how stateless are they anyway? Scaling up, on the other hand, is super easy. You just start a bunch of new ones and they go. So we thought, this is for a cloud native application. It might be just the thing to have the services kill themselves after a while. So maybe after a set number of requests, or when the load is going low, or when after a certain time span or something like that. And then we thought, maybe if the instance itself knows that its load is low, then it can spawn siblings until its load goes lower, right? Oh no, sorry. When the load is high, it can spawn siblings, and then automatically the load will go down. And it will spawn more siblings because the load is probably really high, and then you'll end up with all these instances. But if they kill themselves after a while, you have basically what you have is a distributed scheduler. So without a central hub in Marathon or any kind of framework, distributed scheduling. Pretty cool, right? So I'm going to have a demo of that, hopefully at the next Software Circus. But first, the actual demo that is going to work now. Let's see. Oh, it's over there. Yo. Now it's over here. Hello. Good. Bigger. Bigger still. I need I was going to do this. Yeah, sure. So I need a volunteer. First I'm going to show off our super professional, ultra cool IoT device. This is the level of the professionalism that you can expect from the engineers at Container Solutions. It's a bunch of tape. Right. So an engineer, a volunteer. Oops. To spin the wheel. You can win something, guys. Do you know what the tile is? It's also an IoT device that you can stick on your keychain, and using your telephone or your smartphone, you can then, with an app, you can find it using Bluetooth. It's actually pretty cool. There are two guys of these, two stuck to the board here. So if you land anywhere on them, they're yours. Yeah, sound good? Yay! Right, before you go, look at the requests coming in, right? Yeah. Do it, spin it hard. How hard? Very. I said they would go violently. That's not good enough. You're gonna have to go again. There are no other volunteers, so you have to go again. We can all have a go after, if you like. Yeah, go. Yeah, man, you made it. See, a promise is a promise. And now I can always find you because I stuck it to you. All right, thank you. Any questions? We're good? Eager to get to the beer? There you go.
It looks cool. What are you actually sending there?
Yeah.
From the thing?
I'm actually, yeah, I can show you some green code flowing through the screen if you like, but that won't prove anything either. Right? Do you want it?
The code?
No, well, the log output.
Maybe you can explain a bit how it influences how you read the signals and then what happens
Right.
in the process until it.
Yeah. All right. So one of the prototypes was I wanted to read all the clicks. Right. This turns out to be super hard because there's so much noise going on. So I was one of the I tried a knock sensor, which is like a microphone basically, but no, that didn't work. I tried a bunch of. I tried a vibration sensor. There's way too much vibration going on. I tried to shine a LED on a light dependent resistor, which kind of worked, but that would have been very finicky, and you know. So then I cheated. As I said, engineering prowess at Container Solutions. These are magnets in the back, and magnets always work. So basically what it is a bicycle speedometer using a Hall sensor, which sends its signal to an Arduino with some basic code that reads the signal and reads the spikes and then sends that to a Python script running on my laptop. That sends then the request to the actual cluster run, or I could say cluster. Mini-Mesos cluster also running on my laptop, and that then displays this.
Okay, cool.
So I can't prove it, no. But, there are blinking lights.
But except from scaling up, you said that it's still difficult to scale down. Is that something you, where's the fortune in not scaling down?
Do you mean we shouldn't be scaling down?
No, you should, because there's how many instances just doing nothing, and there's no fortune in doing nothing.
Exactly. You're right. But that is in the next prototype.
Sorry, version 0.
No, but scaling down is currently manual work.
Can you explain maybe a bit in a few words why it's difficult to scale down?
Well, you have to do a lot of bookkeeping, right? Which servers can reliably be killed, and in this instance, this is just for fun, so you can just kill a bunch. But let's say you're running Elasticsearch with let's say 3 masters, and you kill 2 masters because Marathon thinks, oh, these guys are all Elasticsearch. I don't know the difference. I need more space. I'll just kill 2 random guys. Oh, this one and this one. Oh, and the third. Oh, and then you are on a masterless cluster of Elasticsearch nodes, and you're doomed. So you have to do all this bookkeeping in a framework, which makes creating frameworks even harder, right? So if the node itself would in the instance of Elasticsearch, that would be hard because you would have to have some kind of sidecar or whatever running inside either inside Elasticsearch or alongside Elasticsearch. But it's probably easier than doing all the bookkeeping. And if it's not, then you'll hear about it at some other software circus.
Problem with this would be that pretty much every service is stateful, so you would have to drain the connections from it in order not to interrupt them, and this knowledge is shared. I mean, the knowledge of which application container would be killed belongs to Mesos, and HA proxy holds the load balancing data. And I think that Kubernetes have actually introduced a feature which allows you to do just that, but safely. So it first drains the requests from the container, and then kills it.
All right. Oh, that's pretty cool.
Yeah.
Cool. Was it a question? It is very cool, though, right?
Yeah. Well, I just wanted to add what the
All
actual problem is.
Yep.
I have another question. I don't know if it's exactly related. It's about mini-Mesos and Mesos. How do you guarantee that the API that you provide for mini-Mesos is in sync with what Mesos provides? Do you always say, okay, this version of mini-Mesos is compatible with this version of Mesos, and is this in sync all the time? Or the API is fairly stable and it...
So glad you're here, Frank.
Yeah. I will answer this question. So what you can do in mini-Mesos when you start a cluster is you can specify the image that is being used for the cluster. So you can say, I want to have a Mesos 025 cluster or 24, and then it will use those images.
So then you actually, in mini-Mesos, you run an instance of Mesos itself. So you don't reproduce the API or anything?
Yes, we don't reproduce the API. So we create a few containers with the master agents of a particular version, and then we add our own stuff on top of it. Yeah, but you can always use the existing APIs underneath. Yeah.
Any other questions? All right. Well, thank you. You're up.
Right. So, that was Remmelt and his IoT. I don't know if you're following Twitter, but Phil came back to your, aggressive attack of him, and he says, what does he say? 1 second. It's all on Twitter. So you don't actually need to come here. You just watch the stream and tweet each other. He said his perception is that hardware IoT development is miles ahead of software IoT development. Is that correct?
I think he's correct, but there are suppliers that are recognizing the potential of IoT. So, for example, I work with Penthouse software, and they've recognized IoT as a very important step to getting a bigger product out. They were bought by Hitachi Data Systems, who do a lot of IoT, they do a lot of engineering, that have a lot of sensor data, and they're fully committed to IoT. So I don't think the software's there yet, but I think there's a lot of signals going on as to moving in that direction.
Right. Well, thank you. Then there's nothing else to add. Remmelt told you earlier that there's going to be a Software Circus Winter Wonderland. That's a one-day version of the conference which we had in September. The website's not live yet, but the meetup is. The only people who know about it are you lot. So if you want to go, register, tell your friends to register, share the link with them before we do a general announcement, probably tomorrow or Monday. It's free. The speakers are excellent. I think it's Dutch Docker Day today. Tomorrow, awful speakers. Awful. And you have to pay to go. We did the complete opposite. Great speakers and it's free. All right? Just... Yes, I can. What? Simon Brown, Mike Haystack, Frank, David, not that Frank, a different one. Luke Mazda, CTO of Cluster HQ, and many, many more. Marta, talking about visual design thinking and visuals in programmable infrastructure and distributed systems. Right? This is where the action is. Okay, all these other pretenders out there. If you're watching on the stream, right? So log in, register for that. We hope you've had a great time. You don't have to go home. There's beers in the fridge. Feel free to chill out. Alternatively, you can go to Lights Plan and grab a pint. We're always looking for speakers for Software Circus, so if you're interested in talking later, please do so. I think we need a round of applause for our first speaker. Where is he? Yes. We need a round of applause for me. Yes. And a big round of applause for Remmelt and his IoT. See you next time.